Children's Television Workshop presents Square One TV, show number 133, produced at Unitel Video in New York.
Yeah, hello. Are you the guy who sold me the storm windows? Because if you are, I'm gonna... You're not? Who? Liberace, the piano player? Oh, Fibonacci, the number player. What can I do for you, Fib? You found a distant relative's nose? Notes, I say. And what? You've come up with what? This seance? I'm not too interested in seances today. Oh, sequence. You have this kind of number sequence. Yeah. Yeah, okay, I'll write it down. 1, 2, 3, 5, 8, 13, 21, 34, 55. Hey, Fib, fella, I'm kind of getting sequence crap. What's the point of this, Fib? Do I see a pattern? No, I can't say that I do. Add the first two numbers together. Okay, 1 and 1 is 2. That wasn't as much fun as I was hoping, Fib. What? Do I notice one? Huh? Each number in the sequence is got by adding the two numbers which precede it. Let me check it out. By the way, where are you calling from? Pisa in Italy? How's the tower? Still kind of leaning over, Fibbo? Call you Leonardo. Sure. Hey, you know, look, I get what you're getting at. 1 and 1 is 2. 1 and 2 is 3. 2 and 3 is 5. 3 and 5 is 18. Really moves along for a number sequence. Who thought of this? Not you, a distant relative, huh? It was something Leonardo of Pisa came up with in the 13th century? Whew. What do you call this thing? The Fibonacci sequence. What's that? This is only the beginning? Yeah, I'll bet it is, Leo. Look, thanks for calling. Yeah. Bye. Yeah, bye. Huh. Yeah. Harry, I just got a call from Leo Fibonacci in Italy, and you know him? Yeah, that's the guy.
So anyway, there was this man from long ago, 13th century, in the town of Pisa. He was known as Leonardo. Some people called him Fibonacci. And he created a series of numbers that have a wonderful property to them. First, let me show you how to make a Fibonacci series, and then a terrific magic trick that you can use to fool your friends. Now, a Fibonacci series starts with any single digit. Don't let me see what digit you choose, Arthur. And then write another digit under it and add the two together. Okay?
Okay.
Now, add those two and come up with a fourth number.
Okay.
And the third and fourth to come up with a fifth. And continue that pattern until you have 10 numbers. Now, the first 10 digits in the Fibonacci series have a wonderful property to them. I'm going to ask Arthur to add all of those together in just a moment. Here's a stopwatch, because we're going to have a kind of a little, shall we call it a contest. Yeah. Yes, that's good. Have you got
10
that
numbers,
down? Okay, right. 10 numbers. Let me just see. You have all 10. Okay, I'm going to add up all of those numbers, and let's see who can do it more quickly.
Oh, I'm good at this. Okay.
Are you really?
Yep.
All right.
You ready?
Get set. Go.
Go. Okay. 5, 10, 18, 20.
I'm done.
Get out of here.
That's true.
And I got it.
What do you have?
374.
Okay, I did it in about a second. And it took you a little bit longer, about 15 seconds. Yeah. You know why it was so easy for me? Because the Fibonacci series has this unusual property that the seventh number of 10, the first 10 in the Fibonacci series, can be multiplied by 11, and that will give you the answer of the sum of the first 10 numbers. And that will work with any 2 digits if you follow this same pattern. You see, Fibonacci was a wonderful mathematician, and that is mathematics.
That's great.
You like that?
All right.
Mr. Blackstone?
Yeah.
I was wondering if you could change this nickel into $1 for me?
Why?
Well, the ice cream cone man is here, and I'd like a fudgesicle.
Well, nice thing about magic, you don't have to. You have that, and we'll do that, and then we don't have to buy it. You have it right there. That's great. How do you like that?
Looks good.
Remember, the Fibonacci series starts with any 2 numbers. Add them together to get the next number, and so on, and so on, and so on, and so on, and so on.
Mathman, your mission is to eat only percents that are more than 1/2. When you encounter a number, you will have until the count of 3 to make your decision. And beware the evil Mr. Glitch. He will eat you if you are wrong.
Mathman, 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 Mathman.
What is it?
Greater than 1/2.
Yeehaw! Mathman, Mathman, Mathman.
Greater than 1/2.
Mathman, 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 Mathman.
Oh, yes.
Lucky rascal.
Hee-hee. Mathman, 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 Mathman. Yep. Oh. No.
Stand still. Now I'm going home, perchance to Glitch.
King and Queen, there'll be 20 for dinner tonight. And we've arranged the table so they can sit, eat, and pledge allegiance to the crown. What is it, Solari?
Well, there are no chairs. How are they going to sit and pledge allegiance?
So they won't sit. They'll stand on ceremony.
Okay.
What is it, Sir Curly? Come here.
Nothing. What?
Look, you're in charge of dinner tonight. What are you going to serve?
A tennis ball to the back of their hand. Oh, don't take my nose. How will I smell?
About the same.
Terrible.
Oh.
What in Camelot is going on down here?
No, it's Mylan, the magnificent magician. Hello.
Hello. Now, what are you making all this racket for? Don't you know? It's the middle of the night and I'm trying to sleep. Just look at the time. It's 2:45 a.m.
2:45, no one in the place.
Cut it out.
Now, what are you trying to do?
We're setting the tables for the king's dinner tomorrow night. What do you think? There'll be 20 people, so we got 5 tables.
And 4 people at each table.
So that's a total of 20 people. Pretty clever, huh?
Clever. However, I happen to know the king doesn't like his guests spread out. He figures they can't talk to one another that way. He will find this table arrangement unacceptable. The table's too far apart.
Well, that's easy enough. You, line the tables in a row.
Certainly.
There we are. 5 tables at 4 people each equals 20 places, and they can all talk to each other.
Not with their mouths full.
See this?
That didn't hurt.
Wasn't supposed to.
Your new design won't work either. Look, you've lost 8 place settings.
Oh. Mullen is right, Mo. Look what happened when we pushed the tables together. People can't sit here.
Or here, or here, or here.
Yeah.
Oh, my gosh.
You see, when the tables were standing alone, each table had 4 places. But when you join them in a line, each table has only 2 places.
Except at the ends.
Yeah, each end table has 3 places.
Boys, huddle. All right, break. Prepare to move the tables again.
Wait a minute. How come you never do any work?
Yeah.
Ah, that's gratitude for ya. You think it's easy, grabbing you by the schnoz all the time, hitting you on the head, and grabbing you by the ears.
You're 8 plate setting short.
All right, boys, fetch 4 more tables.
Certainly. Whoop. Whoop.
This would work under normal circumstances. However, this room is too small to accommodate them. Who's going to sit out in the halls?
Boys, this'll never do. Rearrange the tables again.
They're heavy.
Yeah, my back hurts.
Now your front hurts too.
However, they are right. There are easier ways to plan a seating arrangement. We could use a drawing. Now, what if we arranged the 9 tables in an L shape?
L stands for Lancelot.
You know how the king feels about Lancelot.
Will that seat 20 people?
Yes, it will, but...
L is for Lancelot.
And you know how the king feels about Lancelot.
Down, boy. He's not too crazy about us either. Okay, the L is out. What else can we do?
Look, Mo, a zigzag design.
Yeah, and it seats 20 people, too. Terrific.
Wait a minute. These people will have their backs to the king. He don't like that.
In fact, he hates it.
Well, scratch the zigzag.
Cut it out.
What if we tried a T shape?
Wait a minute. Where'll the queen sit? If she sits here, these people won't be able to see her. And if she sits here, these people have their backs to her. No, this'll never do. What kind of design will satisfy the king, huh? What kind?
What if we had the royal carpenters build a round table?
A round table.
A round table.
A round table?
Certainly.
What a great idea, Merlin. You are magnificent. Cut it out. Everyone can fit at a round table. No one will have his back to anyone, and everyone can see everyone else. Ha! What great thinking.
Certainly.
Well, thank you. Now, I must be off. I guess I don't know my own strength.
Square One TV's roving reporter asks another mathematical question of the person on the street. Today's question, what is a tessellation?
Tessellation, is that really a word?
It sounds like a boy that's very nervous after a test. Have no idea.
Are these actual words taken from Webster's?
Is it like a test?
A blood test. Operation.
This sounds like a test, okay. That I heard on Sesame Street.
It's another word for a toothbrush.
A tessellation, something that they do to the body, I don't know.
That's a pattern that uses squares and triangles and hexagons, and they're right next to each other, and they don't overlap, and there's no gaps, but it's a pattern of these, like in a bathroom tiled floor or something like that. That's a tessellation.
We're talking about tessellations. Ooh, tessellations. Geometric shape sensations. Ooh, tessellations. Who's got time for good vibrations? We've got to use our imaginations. Ooh, bop. talking about tessellations. Ooh, tessellations. Geometric shape sensations. Ooh, tessellations. Who's got time for good vibrations? We've got to use our imaginations. Ooh, bop, bop, ooh, tessellations. Let's use a grid of squares to tessellate this plane. We'll lay down different polygons. The shapes don't need to be the same. We'll line them up edge to edge so all the sides will meet. We'll leave no gaps, no overlaps. Look at how the pattern repeats. Yeah, we're talking about tessellations. Ooh, tessellations. Geometric shape sensations. Ooh, tessellations. Who's got time for good vibrations? We've got to use our imaginations. Ooh, bop, bop, ooh. Come on and put a square here and put an octagon there. And when they fit real tight, we'll know we're doing it right. Yeah, yeah, we're talking about tessellations. Ooh, tessellations. Geometric shape sensations. Ooh, tessellations. Who's got time for good vibrations? We've got to use our imaginations. Ooh, bop, bop, ooh, tessellations. We're making tessellations.
The story you are about to see is a fib, but it's short. The names are made up, but the problems are real.
It was 2:43 p.m. and the weather in Los Angeles had become cloudy and the temperature dropped enough to make tourists put on shirts. We were working the day watch out of Mathnet. My partner is George Franklin. The boss is Thad Green. My name is Monday. I'm a mathematician. We were busy trying to solve two cases at once. A man named Hans Ballpeen had been kidnapped and someone stole the Despair diamond from millionaire Orson Kane. When you're solving a problem, it's good to go back over the facts. We decided to look at a scene from yesterday's show.
The thing we have to do right now is find out how your security system broke down.
That's kind of like closing elevator doors after the horse has flown the coop, isn't it, Kate?
Not really. If the thief could make off with the diamond.
She's right. He could get back in here and rob me blind.
Wait! Hive said the burger weighs less than we thought. Maybe it's hollow.
Hollow?
You know, empty inside. I mean, even though it has pickles, tomatoes, onions, and hinges.
Hinges.
Injured. Hey? You're injured.
Good work, George. I think we know how our man got in.
Kate, do you know much about the Despair Diamond?
A little bit. It's got quite a history.
Oh?
It's called the Despair Diamond because for years and years its owners have had nothing but despair, sadness, and bad luck thrust upon them.
Really? You mean like it's haunted?
Something like that, I guess.
Well, who's owned it in the past?
Oh, lots of people over the years. Napoleon, Millard Fillmore, Marie Antoinette, Wiley Post.
Who did Kane buy it from?
The Chicago Cubs.
Wow.
It weighs 227.1 carats.
Martha grows carrots.
Not that kind of carrot, George. C-A-R-A-T. A carat is a small unit of weight used in measuring precious gems. A carat is equal to 200 milligrams.
Well, to find out how many milligrams it weighs,
you multiply the number of carats by 200.
that's 45,420 milligrams.
There's 1,000 milligrams in a gram.
That's about 45 grams. But what does that mean?
A nickel weighs about 5 grams, so it's about as heavy as 9 nickels.
That's not very heavy.
It is for a diamond, and it's very valuable. What's that cloth?
This? I found it in the Hamburger at Kane's place in yesterday's episode. Thought I'd ask Debbie to run some tests on it, but I can't find her.
May I see it? Ace. Ace?
That's the name of my cleaner. Ace Cleaning. Maybe the thief has his clothes done there, too.
This isn't clothing. It's like a heavy bag. Just for the heck of it.
Are you looking up Ace in the phone book?
Uh-huh. Ace Advertising, Ace Aerobics, Ace Action Bikes, Ace Achilles Tendon Repair, Ace Party Balloon Company, Ace Balloon Rental.
Kate, I was thinking about how the robber got out of Kane's estate.
Uh-huh.
Remember the problem with the missing baseball when Mrs. McGregor's house was missing and I said, well, it couldn't have just flown away.
Yes, but it did fly away.
Ace Balloon Rental. Maybe the thief flew up, up, and away in a beautiful balloon.
That's brilliant. Let's roll.
Well, hello, folks. I'm Amelia Airliver. What can I do for you?
I'm Kate Monday. This is my partner, George.
Frankly, Mathnet.
We're working on a burglary case and we need some information about hot air balloons.
You've come to the right place. I rent them, repair them, and sell them. I know balloons, ballooning, and balloonists.
I've never heard balloon conjugated before.
What do you need?
First of all, is this from one of your rigs?
Certainly looks like it. I'm pretty sure it is. Why?
We found it at the scene of a burglary. Is this what a balloon is made out of?
Oh, no. That's the heavy canvas bag the balloon is carried in.
I see. We think our suspect made his escape in a hot air balloon. How much trouble is it to get one of them airborne?
Oh, it's not difficult if you know what you're doing. But you do need a bit of room, though, like a big field, for example.
He had plenty of room. You could hold a balloon convention on his front yard.
Well, see, you lay out the balloon, and then you make sure the load cables are straight. Then you fire up your propane burner.
Propane burner?
Yeah. The burner warms the air, and the fan blows the hot air into the balloon. That's how it's inflated. And then we set the gondola upright.
How long does it take?
Oh, depends on the temperature, the size of the balloon. It's a little complicated. I guess you could say anywhere between half an hour and an hour.
Is it a noisy operation?
I guess you could say it is. Why?
The security guards would have heard that, George. Thanks, Amelia. Guess we figured wrong.
Thank you.
No problem.
Thought sure we had him this time. All we had to do was find out who rented a balloon, look up his name in her records, and bingo, we had our man.
We'll just have to keep plugging. There has to be a solution to this problem. What's that?
It's a brochure on ballooning I got from Amelia. Kate. Kate?
What?
What if it wasn't a hot air balloon?
We know it wasn't. What are you talking about?
What if it was one of these?
A helium-filled balloon. Why not? Call Amelia. Maybe they're quieter. While George was getting more information about the balloons, I called Debbie and asked her to get specific weather records for the night of the robbery.
Amelia said it could have been a helium balloon. She rents them, but hasn't rented one recently. She says they are quieter, but you'd need a lot more helium.
Here's the weather report for that area, Kate.
Any winds that night?
Uh-huh. 10 miles an hour steady, gusting to 20.
They could push a balloon pretty far.
Which direction were the winds coming from?
From the west.
Amelia said a helium-filled balloon could travel for days if the pilot puts plenty of supplies on board.
And if it were averaging 15 miles an hour?
Let's say it's been up for 3 days. 24 hours a day, that's 72 hours. 72 hours at 15 miles per hour. 72 times 15, 1,080. The balloon could be more than 1,000 miles away.
According to the scale on this map, 1,000 miles is about 14 inches. And you gotta figure the wind direction changes, so it could be anywhere within a very wide sector.
We can alert the Air Force to keep an eye out for a runaway balloon.
Mathnet, Monday. Yes, Amelia, think of something else? The police called, uh-huh. Yes. Yes, Amelia, that helps a great deal. Thank you.
New information?
Uh-huh. The police just found a balloon in Griffith Park. Abandoned.
Oh, gee, hi, fellas.
Welcome back, Mr. Blotter.
You folks at home, get pencil and paper ready so you can play too.
Well, we might just know how our man got into the Kane estate and how our man got out of the Kane estate.
Yeah, if only we knew who our man is.
100% of Square One TV is a production of the Children's Television Workshop. This program was made possible by grants from the National Science Foundation, the U.S. Department of Education, the Corporation for Public Broadcasting, the Andrew W. Mellon Foundation, and the Carnegie Corporation of New York.
Corporate funding is provided by IBM. At IBM, we believe education is the key to the future. We are pleased to help support Square One TV as an innovative way to introduce young people to the exciting world of mathematics.